Hi guys, see you again in mechanism of alkene. So now we look at the second mechanism of alkene, which is hydrohalogenation. Okay, so before this we already looked at the preparation of alkene mechanism, which is dehydration of alcohol. Now we are going to focus on chemical reaction of alkene, hydrohalogenation. So as we know that in hydrohalogenation, alkene will react with hydrogen and halogen, either HCl, HBr. Okay, so now we are going to focus on the mechanism of hydrohalogenation. Alright guys, in this mechanism consists of two main steps, which is the first one is formation of carbocation and halide ion. How? Like this class. Okay, look here. So we have carbon-carbon double bond as alkene. So we know that carbon-carbon double bond is electron rich. So carbon-carbon double bond will be our nucleophile. So the HBr or HCl here is the polar molecule, will be the electrophile. So we are going to add this hydrohalogen, kan? Hydrogen dengan halogen dalam carbon-carbon double bond. Okay, so the first step here, kita akan buat formation of carbocation. So apa yang berlaku dekat sini? One of the double bond here, okay, the double bond here will attack hydrogen, and this bond between hydrogen and halogen will break. It means that both electron here will go to halogen. Okay, so look at the arrow that we use here, the full headed arrow. So what happened? So kita tahu hydrogen ni kita akan masukkan kepada carbon double bond yang banyak hydrogen sebab dia follow Markov-Nikov rule. So kalau hydrogen dah masuk, so one of the carbon-carbon double bond tadi akan jadi carbocation. No more double bond here. So this halide ion, kan, dia membentuk this halogen atom tadi membentuk halide ion. Sebab apa dia negative charge? Sebab dia accept 2 electron from hydrogen tadi, kan? So dia jadi negative ion. Okay, so this is the first step. Okay, the second step, halide ion donate electron pair to carbocation. Okay, before that class, bila ada formation of carbocation here, you need to be careful because sometimes it will undergo rearrangement if the carbocation is unstable. So you need to be careful here. Okay, so either it will undergo 1,2 hydride shift or 1,2 methanide shift. Okay, so the second step, this electrophile will react, this carbocation just now will react with the halide ion. Tu je sebenarnya, tak ada apa pun, lagi senang. So kita tahu negative ion mestilah kaya. Di nucleophile tengok ni, lone pair kau main banyak. So dia akan attack carbocation. So look, the arrow that we use, satu arrow sahaja. So one of the lone pair, mana-manalah lone pair ni. Sebenarnya lone pair ni kalau awak tak nak lukis pun tak ada masalah. Okay, so dia akan attack carbocation. So dia akan bentuk ikatan dengan carbon tersebut. Itu saja. Nampak tak? So kita akan masukkan hydrogen dan halogen. I think this mechanism very simple, but be careful when the formation of carbocation. Okay, next we look at the example of the mechanism for electrophilic addition of HCl to 2-methyl-2-butene. So we look at the example here. So this is 2-methyl-2-butene. Okay, so we'll react with HCl. So we are going to add HCl into the carbon-carbon double bond. So the first step, so ingat, step 1, step 2 tu tak payah tulis pun tak apa. Kita terus je create dia punya mechanism. Okay, first step as usual, the carbon-carbon double bond will attack the hydrogen. Nampak tak? Okay, dia akan attack hydrogen. So arrow ni lukis betul-betul ya kalau awak lukis. So kemudian the bond between hydrogen and chlorine will break. So 2 electron here will move to chlorine. Nampak? 2 arrow dekat situ. All both arrow is full headed arrow. Okay, and then the formation of carbocation and halide ion. So Cl minus kan. So kita ada Cl minus kat sini. Okay, Cl minus ni kalau tak nak tulis atas arrow pun tak ada masalah. Tulis kat sebelah sini pun boleh. Okay. So kalau awak tengok kat sini, look at the carbocation form. The carbocation form is tertiary carbocation. So as we know that tertiary carbocation is the most stable. So look at the neighbor carbon. Kan, carbon yang sebelah kanan, carbon ni secondary. Tengok pula carbon sebelah kiri, carbon ni primary. Tengok pula carbon yang bawah, primary juga. So tak boleh lawan yang asal. So the original carbocation here is more stable compared to the left carbon here, the right carbon and the below carbon. So no need rearrangement here. Nampak tak? Tak perlu buat rearrangement. Okay, so teruskan dengan second step. So this halide ion will attack the carbocation. Nampak tak arrow dia? Daripada klorin terus pergi kat carbon. Okay, so this lone pair tak nak lukis pun tak apa, tak ada masalah. Alright, so you akan dapat this product. So Cl terus masuk dekat carbocation tadi dan kita dapatlah haloalkane. So very simple mechanism here because no rearrangement involved. Guys, thank you. That's all for hydrohalogenation mechanism. I will see you with the third mechanism. Bye guys.